Hey guys, so we're up to 6D, which is solving cubic equations. We've actually done solving quadratic equations before, so what I'm going to do to start with is just kind of jog our memory because it's actually done for cubics the exact same way that it's done for quadratics as well. So this is a quadratic equation that we've got and we're trying to solve it. That just means we're trying to solve for x. So to do that, we could follow these couple of steps here. So we have to factorize, and then we solve for each factor. So if I factorize this, it would become, what is it? X plus 1, x plus 2. There we go. And then all we need to do is use our null factor law. So make our y or f of x equals 0. There we go, we're fully factorised. Now we just need to solve for each of these. So it would be x plus 1 equals 0, which means x is minus 1. And we also have x plus 2 equals 0, so x is minus 2. That process that we did just then is the same as we're going to do for any cubic equation that we're trying to solve for. The only reason it's a little bit harder for cubics is we need to use long division and factor theorem in order to factorise first. So firstly, we'd use factor theorem. Then long division. And doing that is going to give us our factorised form. So in this case, I'm not doing this in my head for this example here. I did it before. Once it's factorised, it's going to become this. There we go. So hopefully we can do that kind of thing because that's what we did in 6C, but we're going to practice some more today if we're not fantastic just yet, which is fine. So we're fully factorised. Now we're just going to solve for each of those factors. So null factor law again. So we can see that our x is going to be minus 1, x is going to be minus 2, and x is going to be minus 3. There we go. So hopefully you can see that what I did over this side with quadratics, which we're more familiar with, is super similar, pretty much the same thing as what we're going to do for cubics as well. So let's go to our first couple of examples. So we just want to solve for x, which is mainly what you're going to be doing during this exercise. So with this example here, this is a cubic that's already been factorized. We don't need to do that. It's done for us. So all we need to do is solve for each of these factors. So this isn't anything new. So this x is going to be 4 because x minus 4 equals 0. So x has to be 4. This one's going to be 1 and this one's going to be negative 2. We're finished. That's it. We've solved for x and there's 3 different answers. Now this one here, what I want you guys to look at before you try to solve for x for any of these is see if there's anything that's common throughout all terms. So if I look at this one here, I can see there's an x here, and there's an x here as well. So I can actually take x out as a factor, and that's going to make it a bit easier for me. So if I take that x out, we're going to have this. There we go. So now we can see that we have a quadratic in here. Now we should be able to factorize this one the same as we did with this one up here as well. Okay, so I can see that we need the factors of negative 3 that add to make negative 2. So that's going to be x minus 3x plus 1. And we are factorized. So now we're doing the same step as we did over here. X equals 0 is our first answer. X minus 3 equals 0, so x equals 3. X plus 1 equals 0, so x equals minus 1. There we go, we've got our answers. Now this next one is going to be the last one we do in this exercise, but we're going to kind of put the whole process together. Alright, so we're going to involve using the factor theorem so we can find a factor, and then we're going to use long division so we can find more factors. Okay, so firstly, I want to find that factor. Now, I want to test if x, what am I going to choose? X minus 1 is a factor. I want to see. So what I need to do is substitute in not -1, but 1 into this rule. Now, if this ends up equaling 0, then we have a factor. So let's see what it comes to. Okay, so it looks like we've got definitely a negative number there, so it looks like that one won't be a factor, so no good. What did it come to? Minus 23 plus 3, so minus 20. Therefore, x minus 1 is not a factor. So that's no good. That didn't really help us. Let's try another one. I'm going to try x plus 1. So let's do the same thing, except instead of putting in plus 1, we're putting in minus 1. We've substituted in. Let's see what it comes to. Okay, so it looks like that's going to be 0 minus 1. Sorry, just one second. Sorry about that. So that comes to 0. So therefore, we can say that x plus 1 is a factor. So we found our first factor. Awesome. That's the first thing that we needed to do. So next, we're going to use long division, and we're going to divide our original polynomial here by this factor to find out what the other factors are. So x plus 1, and we've got x power 3 plus x squared. Alright, our long division is set up. We've just got to get into it now. So x power 3 divided by x is x squared times x, and then x squared times 1. Now we're up to our subtraction step. That minus that, 0. That minus that is x squared, and we bring the next term down. And now we're focusing on this bit again. So x squared divided by x is x. X times that, then x times that. Now up to subtraction again. That minus that. That minus that. And we bring our next term down. Now we're focusing, now we're focusing on this bit. So that divided by that. Yep. Now we need to take this and times by both of those. Subtraction step. That minus that, so that plus that is 0. That minus plus that is 0. Awesome. So that did work out that that was a factor because our remainder is 0. So I just want to clear up where we started and where we are now. So initially we had this rule. We had that rule there. Now that we've factorised partially, we have our x plus 1 as one factor. We found that up here. And now the other factor that we have right now is a quadratic one, which is what we got from our long division. Cool. So this should hopefully look pretty familiar. All we need to do now is break this one up into linear factors because it's currently quadratic. Okay, so oops. Alright, the factors of minus 12 that add to make 1. Factors of minus 12 that add to make 1. So plus 4 minus 3. There we go, we're fully factorised. But we were asked to solve, weren't we? So now that we've factorised, we can solve, because all this is going to equal 0. I didn't have to do f of x before, I could have had it as 0, as it said at the start up here. So it already had it in null factor law, but that's okay, I can write f of x instead, it doesn't really matter. There we go, so we can see that x is going to be minus 1 from that one, x is going to be minus 4 from that one, and x is going to be 3 from that one. And we're done. Alright guys, have a look at the questions I want you to do in the lesson plan or in the learning matrix. If you've got any questions, make sure you're posting them so I can help you as soon as possible. Thank you guys, see ya.